Good afternoon, everyone. Let me just move that. So my name is Richard Lilley. People know me as RJ, and I am a seagrass scientist. I am a Director of Project Seagrass. I'm currently based in Edinburgh, although I did my PhD down at Cardiff University and a Master's at Cardiff University and another Master's before that at Swansea University. All of those on seagrass. All various aspects of seagrass, either ecology or seafood supply chains. But basically I've been working with seagrass meadows now since 2011. So yeah, I moved to Scotland 4 years ago, and really today I just want to talk to you a little bit about what we're hoping to achieve in Scotland, and really I guess where we've come from, what we've been doing in Wales in terms of seagrass restoration, and how we see that fitting into this upcoming decade on ecosystem restoration. The talk's titled Gardening Under the Sea, Bringing Biodiversity Back to Our Oceans. At the moment, I think we are probably still at that gardening level, but we've definitely got aspirations to scale up and to restore seagrass meadows on a much larger scale than what we've been able to achieve so far. So please follow our journey. So, like I mentioned, the upcoming decade is this decade on ecosystem restoration. The UN has formally declared this on March the 1st, 2019, and the reason for this is frankly we're losing nature at an astonishing rate. We've got severe concerns about the rate of change of the climate, and two ways that we can mitigate some of those effects is just simply by restoring nature. In the same way that if we were to restore terrestrial forests, that would help capture carbon and create three-dimensional habitat for a range of different species to inhabit. It's exactly the same with our seagrass meadows. You know, if we can start restoring our seagrass meadows, we create complex, productive, three-dimensional habitat for a whole suite of different organisms to live in, and also we've got the carbon capturing or carbon sequestering ability of seagrass meadows, which vary, but at their best, sort of the Posidonia species can be up to 35 times faster than tropical rainforests. So significant carbon stores. And so the UN wants us to restore. And so, you know, in terms of a narrative, that's something that we're at Project Seagrass certainly looking to buy into with our partners in WWF and Cardiff and Swansea University over the next 10 years. But these goals aren't, I guess, really new. It's a decade, it's an official decade, and it's nice to be able to work towards something like that. But, you know, we've previously had the Millennium Development Goals and more recently the Sustainable Development Goals, which Scotland adopted fairly early. So, you know, we're looking to contribute through seagrass restoration to meeting some of these goals. Some of them are fairly obvious, life below water, or, you know, climate action, but others perhaps less so, you know, looking at food security and seagrass's contribution to fisheries, sustainable communities, you know. And so if you think about it, you can probably link a lot of restorative work to several of these goals, if not all of them. But before I go into too much detail around the work that we're doing, I just thought I'd give you a quick Seagrass 101. So seagrasses are pretty much exactly what they sound like. They're grasses that, although they're not related to grass, but grasses that look like grass that live in the sea. So in comparison to algae, they have roots and a rhizome, so they'll put their roots down into the sediments and create these root systems which anchor them to the sea floor and into the sediments. And so they're actually a plant rather than an algae. They're easily recognisable. There's only 2 species here in Scotland or around the UK coast, although there's 72 species, I think, at last count globally, and they can come in all shapes and sizes, from very small carbohydrate-rich species just a couple of centimetres long, which are the favourite food of sort of manatees and dugongs, to things like turtle grass, which obviously is a big food source for sea turtles, to the Posidonia species that I mentioned earlier, which are almost like the oak trees, I guess, of the seagrass world, which are very long living, have got huge canopies, so they can grow to, over a meter, or in case up to maybe 2 meters in length, and create very complex three-dimensional habitats with very thick root systems, and which sequester a lot of carbon. So huge diversity, I guess, within seagrasses. But I'm going to be focusing on two, or actually really just one in this talk today. So, yep, 2 species in Scotland, both are eelgrasses. One's called dwarf eelgrass, so that's Zostera knowlti, and that's the picture here on the right-hand side. It's quite a diminutive plant, very small. It's found high up on the intertidal, so it can be exposed for long periods of time, and it makes an important food source for wildfowl, things like brent geese, widgeon. Another migratory species will stop at wildlife basins such as Montrose Wildlife Basin, or some of the flats up in the Cromarty and the Dornoch, where knowlti exists, and they will gorge themselves on this plant. So that's dwarf eelgrass, and again, quite a diminutive small plant, but the one that we spend a lot of our time working with, because of its contribution to fisheries and food security and blue carbon, is this one on the left hand side here, and it's Zostera marina, so eelgrass. It's physically bigger. It can grow up to, I think the biggest leaf I've seen here is probably 1.5 meters in length, although it varies massively. I've just been up in the Dornoch and Cromarty, and at this time of the year, if it's found in the intertidal zone, it can maybe only be 20 centimeters long. So huge plasticity, I guess, in its phenotype. But it's the plant that this talk's really going to be focused upon. And it's subtidal, critically. So even though it is found sometimes in the intertidal, it's found further down the shoreline than the knowlti. So yeah, so I guess we all learn in school about plants and primary productivity, and so if you cast your mind back to when you were 14, 15, 16, it's the same science. It's a plant. It produces biomass from sunlight, so it's found in shallow coastal zones, and as the plant grows, it creates a three-dimensional habitat. Herbivores can graze on seagrass, but critically also it provides a three-dimensional surface for algae and other epiphytes to grow on, and then you get grazers, isopods, gastropods, various little critters, crustaceans, juvenile fish that live in amongst the canopy. And so compared to a bare sand habitat, it is significantly, perhaps up to 40 times more creatures live in a seagrass meadow than adjacent bare sand. Some of those are quite iconic species, like the seahorse. Some are really important for our sort of national food security in terms of the food fish we eat, such as juvenile Atlantic cod. But it can be anything in between. We see in our seagrass meadows, we see eggs being laid on the blades. We see foraging activity from predators who swim in amongst the seagrass meadow to graze on juvenile fish and small other smaller organisms. So it's a hugely productive habitat, and really hotspots for biodiversity in our coastal zone. And then the other thing is, I guess, linked to climate change, is the carbon sequestering capacity of seagrass meadows. The headline figure that you may have seen for seagrass meadows is this figure of 35 times more effective than tropical rainforests. Now, that's not the UK species. It is true of seagrasses, but it's not true of Zostera marina. Although Zostera marina is an effective blue carbon habitat in its own right. One of the things we're finding out about Zostera marina is it really does depend upon where you plant Zostera marina or where it occurs. If it's an exposed area as opposed to a sheltered estuary, the amount of carbon it sequesters varies. And so the exact science or the clarity around that data is still out there. But what we do know is it is a significant contributor to carbon sequestration. And I guess this figure here from 2009 is indicative of the role that seagrass meadows play globally in sequestering carbon in our oceans. I've seen this figure range from 10 to 12 to 15%, but whichever way you look at it, it's still a significant contributor to global blue carbon stores. So 2 football pitches. We always work in football pitches. One, because that's what we've planted. So in Dale, in Wales, over the past 18 months, we've been working on a project which has been planting 2 rugby pitches worth of seagrass meadows. That's 1 million seeds that we've planted down in Dale. But also 2 rugby pitches because globally we're losing 2 football pitches or 2 rugby pitches worth of seagrass every hour. So 2 hectares of seagrass every hour. So we've spent 18 months putting 2 back. But by the time I finish this talk and everyone's gone home, we're going to have lost another 2 football pitches somewhere else. So, you know, it's great to be restoring these habitats, and it's great to be restoring them here in the UK, but globally seagrass loss is still a significant issue. How do we know we've lost the seagrass? Dr. Alex Green has just graduated, or not just, last year graduated with her PhD, and she was looking at exactly this question. So if we look at modelled seagrass loss, we can see that in the 1930s, here in the Yorkshire Humber, a significant amount of seagrass was lost. That was due to a wasting disease. We can see since the 1970s, we've lost seagrass meadows in some of our other coastal estuaries, down here in Essex and Suffolk. And then over here in Cornwall, compared to the 1990s till now, you can see a decline in seagrass habitat. So one of the things that we need to sort of, I guess, account for is the fact that the data, like our data on seagrass, is poor. Seagrass data is often being sort of folded into mudflat data, or people haven't necessarily had particularly good records on, let's say, seagrass distribution and extent. But based upon these models, if the UK has lost 90% of its seagrass, that's a significant loss. You know, even if we'd only lost 50%, we should be really concerned, or 20%. But to be anywhere near 80 or 90% is a massive concern, and really means that we should be putting all our efforts into making sure that we can get these seagrasses to return, and that we remove the threats critically that have been causing seagrass to be lost in our coastal zone. So restoration, we see restoration and large-scale restoration as being an important way of doing this. Water quality around the UK is improving. Marine spatial management and you know, the use of the coastal zone is improving. Maybe not always as fast as we would like, but it is improving. And with improved water quality comes an opportunity for seagrass restoration. One of the most famous seagrass restoration projects globally is in Chesapeake Bay. And over the past 20 years, they've restored 36 kilometres squared of seagrass, so 3,612 hectares of seagrass. And I think they only planted around 600 hectares of those with using 70 million seeds. So, you know, once you've kick-started that ecosystem and you've kick-started the recovery, the seagrass will recover itself. You just need to give it that helping hand to get it started. Until now, until we started Seagrass Ocean Rescue in Wales, there's been no significant full-scale projects on seagrass restoration in the UK. We've only ever been doing trials. I think at Project Seagrass we've been doing trials probably for 6 years. But they've all been very small scale, and we've been trialing different methods, basically exploring the science as to the most effective and economically efficient way of restoring seagrass meadows. The Chesapeake's a different beast really to the southwest of the UK with its huge tidal ranges, and so we've had to come up with some pretty bespoke methods for trying to restore seagrass at scale, and that's what I want to talk to you about now. So just as again a bit of a seagrass 101, zosteramaryn is a plant, so it flowers, and once it's pollinated, it will produce these seeds, and these seeds will fall off and they'll land in the sediment, and then once they're in the sediment, ideally they'll germinate if they're in the right conditions, and that will grow into a new plant, and so on and so forth. So seagrass meadows can reproduce reproductively. They can reproduce sexually, or they can also reproduce rhizomatically, so they just grow sideways from the original plant. The key to restoration is to think big. So when we've been trialing restoration, it's always been small scale up until this Seagrass Ocean Rescue project, and so you weren't seeing some of the gains that you'd like to see, because you're not really changing the ecosystem that much. If you're only planting 20 bags, it's not going to have a significant impact on a bay. But if you're planting two football pitches, 2 rugby pitches worth of seagrass, then that begins to have an impact on the water quality and the sort of I guess physical or abiotic factors within the bay. So what we see is that the more seeds and shoots that you get, the higher the survival of the plants overall, and the better the growth. So when we're looking to restore restoration at scale, is key. The science behind that is fairly straightforward. It's to do with feedback loops, but basically when you've got more seagrass, the seagrass traps nutrients and particles in the water column, and all those particles basically will settle down in between the blades and find their way down towards the rhizome, and that keeps the water column clear so that light can penetrate and the plants and the seagrass can grow and do very well. And that also means that you get algae and epiphytes growing on the plant, which means on the seagrass, which means that you get these grazers, the prawns, the isopods, the gastropods, the juvenile fish and small fish, and that makes for, again, a highly biodiverse, highly productive ecosystem. Conversely, if you lose seagrass, or you don't restore at scale, then you still have a lot of sediment which can get resuspended, so the water quality doesn't improve, or it stays pretty bleak. You get lots of particles in the water column, but also nutrients released, and those nutrients can be our food for phytoplankton and zooplankton, again, which reduces the water clarity and prevents seagrass recolonizing. So really it is about scale when it comes to making sure you have the positive feedbacks and not the negative feedbacks. And I guess what this means for fish is due to the same sort of science, really. If you're a fish and you're living over here on this bare sand or this bare sediment, the water can be very turbid. You're exposed to predators. You're not sheltered at all, so you're having to fight against the water current, and you're expending a lot more energy, darting around, being generally a lot more nervous about being eaten. And also there's no real food there. It's not a productive ecosystem. You don't have the plant or the primary producer, and so all in all, it's a pretty poor environment for you to be hanging out in. Whereas over here on the right hand side, in this lovely seagrass meadow, we've got a very happy fish. Low energy expenditure, gets to hide in amongst the seagrass, plenty of food to eat, lots of crustaceans and other critters, and also you can hide from predators. So we want to make our fish as happy as they can be. We want to get as many juvenile fish as we can in our coastal zone, because fundamentally juvenile fish, more baby fish equals more adult fish in the long run. And one way we can do that is by restoring our seagrass meadows. So I just want to talk you through the sort of 4 stages really of seagrass ocean rescue, or restoration at scale, or restoration at any scale really. And it's the science is fairly simple. So if you have a look at this, this is stage 1. It's picking and spade collection. This is the diver, and you can collect them by diving or snorkeling, or you can collect it even at a low tide, just walking out. But in amongst the seagrass meadow here, you can see these lime green shoots. Those lime green shoots are the spades, which the seeds are in, and so it makes it very easy to identify where seeds are when you're swimming along, and you can easily pick those lime green spades. An up-close version of those spades looks like this over here. So you've got a spade, and within it's like peas in a pod. within the spade, you've got perhaps 8 to 10 seeds in each spade, and on each plant, maybe 3 to 5, 4 to 5 spades. So you can swim along and collect quite a few seeds quite quickly. And all we will do is we'll put them in a bag whilst we're down there, and we'll bring those back to the shore for processing. So stage 1 is picking, and it's just mass collection of seeds. Stage 2 is essentially the separation of those seeds, and what we're looking to do is we'll bring back the spades with the seeds in them, and all we do is allow the spade to rot away, leaving the seeds. So you can see here lots of seeds in amongst that rotting organic material. And same over here, you can see some seeds amongst the rotting organic material. We've got these tanks, flume tanks, sort of bubble throughs, where the spades will tend to be a little bit more buoyant and float, and the seeds will drop down to the bottom, and we can collect them at the bottom. But essentially all we're doing is physically separating the seeds from the rest of the organic matter. And then once we've got those seeds, we're essentially allowing them to harden and go from a lime green colour to a dark brown colour. And then at that point, they'll be ready for planting. So picking, processing, packing. So we pack 50 seeds per bag, and basically we take a little Hessian bag, which is biodegradable. We fill it with sand, and we put 50 seeds into the Hessian bag. The reason we put 50 seeds in is because seed germination amongst the species is quite poor, maybe only about 5%. So by putting 50 seeds in a bag, we're guaranteeing that from a bag, at least one seed will germinate and be successful. And then we'll attach all those Hessian bags to some sisal rope, again, which is biodegradable. And then that 100-meter line of sisal rope with a bag attached every meter is then ready to go out on our rib for planting. So picking, processing, packing, and then planting. So this is our bags of seagrass seeds lines. But basically, we just take out onto our ribs, onto our boat, these sisal lines with the Hessian bags, and we'll slowly lower those bags over the side of the boat, and so they'll land on the seafloor at every meter. And all we're looking to do is essentially drop one line off over the length of 100 meters, turn around and do another 100-meter line beside that, turn around, another 100-meter line beside that, and that way we get to cover the length of the river pitch, or the 1 hectare. And then obviously the final thing then is to check that actually they are germinating, and that's just the ongoing survey and monitoring we're doing. So after lockdown 1, the first lockdown, the team was able to get out to the site and check on the bags. So you can see here there's been, from this particular Hessian bag, there's been two seeds have been successfully germinated. So they're side by side here. And what we'll see over the course of the next few years is that these plants will grow rhizomatically and start to cover a much larger area. And there'll be another Hessian bag here germinated, and that will start growing towards this one. And essentially, the seagrass meadow will fill out over the next few years. So there's just an ongoing surveying and monitoring. I guess that's what we want to try and recreate up here in Scotland. But again, one of the things we're looking to recreate that in Wales and hopefully in England as well, but at scale. So 2 hectares is brilliant, but it's not going to have the benefits that we want to see if we can't scale up. So instead of restoring 2 hectares, we need to be restoring 10 hectares, 100 hectares, which is going to need to mean that we need to do some mechanization of some of the processes. We need to enhance the amount of seeds we can collect. We need to enhance perhaps the planting process and the processing process. But that's what we're working on currently. But I guess of particular interest to the talk today is what's going on in Scotland. So I've moved up to Scotland 4 years ago, and have been doing some of the groundwork, I guess, for restoration in Scotland. I've obviously still had work in Wales, but one of the projects I'm working on at the moment with Nature Scott and the Botanics is trying to get a better understanding of, I guess, morphology of seagrasses in Scotland, distribution, but also genetic connectivity. So this autumn we've been working, collaborating on a genetic connectivity project, so that we can understand where, if you wanted to move seeds around Scotland, where we can move seeds from and to. Like, is it wise to be moving seeds from Shetland to Argyll, for instance? Or could we import seeds from North Wales, where we know there's a highly productive meadow, and plant those in Argyll? Are the plants genetically similar enough for that to be a wise thing to be doing? Or basically we need to fill some knowledge gaps before we can start moving stuff around. And so I've been working with the Botanics, and the Botanics doing the genetic analysis for us on that monitoring and surveying, and between between Nature Scott, Botanics, and Project Seagrass, we're hoping that by March we'll have a better understanding of what potential management units for seagrass meadows might look like in Scotland. What can you do? I guess one of the things that has been a huge help to us has been our citizen science program. We've got something called Seagrass Spotter, which is a citizen science platform where people can submit their sightings of seagrass around the UK, in fact around the world. But for me, it's been particularly useful in Scotland, as it's enabled me to go to sites and visit sites which I didn't know existed, based upon existing data. So to give you an example, this is the work of a community group in the south of Skye. They're called the South Skye Seas Initiative, and they've been mapping seagrasses in and around their local area. And this is allowing us to get GPS locations for seagrass meadows, which are present now. We've got historical distribution of seagrass. We've got some data for that from the 1800s and 1900s, but if that meadow hasn't been there for 50 years or 80 years, then a lot's changed in that time. So one of the things that we're looking to try and ask enthusiastic members of the public is, can they help us by just simply taking a photo of seagrass when they see it and uploading it to this site, and that data can be shared then with Nature Scott. One of the reasons why I am optimistic in Scotland is that we've got a lot of motivated community groups in Scotland who want to see positive change in their marine environment. I think this is embodied by the Coastal Communities Network. You'll see here there's 17 different groups who are part of this network at the moment, and they're all at different levels of, I guess, maturity or capacity, but they've all got one thing in common, and that's a sort of passion and interest in their local marine environment. I've worked with a few, so for example, the group there, number 16, South Skye Seas Initiative, that's the group who's submitting that data to Seagrass Spotter. But also, there's other community groups here, Craigness Restoration of Coastal and Marine Habitat, CROMAC, so that's number 5, who might be interested in restoration activities with regards to seagrass. They're already restoring native oysters through their charity Sea Wilding, but certainly there's been a lot of positive interest from these community groups, or a lot of these community groups, about active marine restoration in the coming years. So I think in Scotland there's obviously the opportunity for these larger large finance Sky Ocean Rescue style projects from sort of progressive corporate partners, but I think there's also a real grassroots movement which might see some significant positive benefits with regards to restoration, not just of seagrass meadows, but native oysters and salt marsh over the coming years. I guess one of the successes which I think is worth celebrating from this group is the nomination of the Mission Blue Hope Spot on the West Coast. So that was nominated by 4 of the groups, and was announced last year. And it covers a large area, all the way from the north coast of Mull right down to the Sound of Jura. And really, for me, if we can offer hope to the Hope Spot by not only offering it sort of special recognition and various degrees of protection which are already existing within there, but also restoration of some of its seagrass meadows and its native oyster reefs and mussel beds, perhaps, then really we can really start to see the ecosystem services, which is science part of the gains, that the biodiversity and climate change gains that we'll have from a functional coastal marine, or functional and intact coastal marine ecosystems. So I guess that's pretty much where I ask you if you've got any questions.